Hi dear. So last class we have seen the structure of the human eye. Today we'll see the power of accommodation. Okay. Before that we'll see do you know part. Okay. Uh, in that you will be asked this question. Yeah, this is the frequently asked question. One of the question. Why do we feel darkness once we enter inside a room after being in sunlight for a some time? Okay. So when you are in the sunlight, how your pupil size will be? Because since you are standing in the sunlight, you will receive more light, more intense bright light. Okay, the eyes cannot withstand that. Okay, so with the help of iris, the size of the pupil will be reduced, right? Your size of the pupil will be small, so that only a small amount of light will enter this. Okay, so it will be the size of the pupil when you are standing in the sunlight. Okay, once you enter a room or any dark room, even if you enter a room, you will feel that it will be very dark, right? Why it happens? Once you enter, your eyes size of the pupil will be the same, right? So it will take some time to expand the size of the pupil. Okay, once you enter the room or dark room, you need to expand the size of the pupil so that lot more amount of light will enter and you can see the object clearly. Okay, it will take some time. This is when you are standing in a sunlight. When you enter the room, once you enter, suddenly your eyes size of the pupil will be same. Okay, it takes some time to convert from this size to this size, right? So that is the reason. Okay, so it takes some time to see the object in a dark room when you enter the room from the bright sunlight outside, because in the bright sunshine the pupil of our eyes is small and hence little light enters our eyes and we cannot see properly. Okay, the eyes need time to adjust and the iris muscle need time to dilate the pupil. That means you expand the pupil or wider the pupil so that more light can enter the eyes and we can see the things properly. Okay, once you entered, after few minutes or second, not minutes, within seconds, you are able to see the things clearly. Okay, so it needs some time. Okay, next one is power of accommodation. So what does mean by power of accommodation is, it is the ability of the eye lens to adjust its focal length. While we are studying the structure of the human eye itself, I told you the length of the focal length of the lens will change, right? Okay, who controls the which controls the size of the lens? The ciliary muscles, right? So it is the ability of the eye lens to adjust its focal length so that the image is always formed on retina irrespective of the object distance. Okay, irrespective of the object distance, wherever the object distance may be. Okay, whatever the object distance may be, but you will get the image at the retina. Only when the image is formed on the retina you are able to see the image, right? Otherwise it will be blurred, right? So power of accommodation is nothing but the ability of the eye lens to adjust its focal length. Okay, to adjust its focal length so that the image is always formed on the retina irrespective of the object lens. Okay, okay, how it changes its length we'll see. Okay, see, this is your eyes, this is a bulge part, and you will have this lens here. Okay, lens. Okay, for example, if the object this is your principal axis, your object is here. Okay, so so when the object is here means definitely it will be parallel to the principal axis. Okay, it will be parallel to the principal axis. So principal axis, and it will converge and you will get the image at this place, right? Okay, okay. So the image is formed on the retina. Okay, in the second cases, same object when it bring nearer to the eyes. When it bring nearer to the eyes, here then also it is able to converge, and you are able to get the image, right, at this point. How is that possible? You know that this focal length is constant, right? Here the focal length is constant means how the image will be formed on the retina, even the object distance differ. Okay, you know the lens formula, 1 by f is equals to 1 by v minus 1 by u. Okay, this image distance is constant. This is your image distance, right? This is your image distance. This is constant. There is no change in that. But we are varying this. We are changing this u distance. This is your u distance. This is your u distance, and here this u distance. But still it works. How the image is formed here? Even if you change the distance of the object by changing the focal length. This focal length is variable. Okay, this focal length is variable. Okay, when the object is very far away, then with the help of the ciliary muscles, it will be relaxed. The ciliary muscles will be relaxed, and the lens become elongated, slightly elongated. Okay, that it will be thin at that time. Okay, so that when it is thin, the focal length will increase. The focal length of the lens will increase. Okay, the focal length of the lens will increase. Now when the object is nearer to this, the ciliary muscle compresses and the curvature of the lens will be increased. Okay, it becomes thick. Okay, so if it is the curvature of the lens is more, means your focal length will be decreased, obviously. Okay, so likewise, based on the distance of the object, the convex lens crystalline lens will change its shape. Okay, how it happens? We have seen the lens, right? It is rigid. It cannot change its focal length. Okay, for this you will have a fixed focal length. But how it changes its shape means, because this eye is made up of fibrous and jelly like material. Okay, so that it is transparent and it is flexible in nature. So that makes the lens to change its size. It can be elongated or it can be compressed. Okay, so if the object is far away from our eyes, means your lens will be elongated by relaxation of the ciliary muscles. Okay, your lens will become thin lens and focal length will increase. Okay, when it is nearer means nearer to your eyes, means it will be compressed. The lens will be compressed in size when ciliary muscles contract. Okay, it becomes a thick lens and focal length will decrease. Okay, all this are possible when the eye lens is made up of a flexible material. Otherwise it cannot change its shape. The curvature of the lens will not change. Okay, the eye lens, it is composed of fibrous jelly like material, so that its curvature can be modified to some extent by the ciliary muscles. Okay, it can be controlled by the ciliary muscle. Thus the change in the curvature of the eye lens can change its focal length. Once the curvature is changing, your focal length will also change, right? For example, see, this is your lens, means your focal length will be half of the radius, right? Half of the radius. If suppose the same thing, if this curvature is big, means your focal length will be half of this, right? This much length, right? So it depends upon the focal length depends upon the curvature of the lens. Okay, the focal length of the eye lens cannot be to some extent only we can elongate the lens as well as compress the lens. We cannot fully compress. Okay, to some extent only we can compress the lens. The focal length of the eye lens cannot be decreased below a certain minimum limit. Okay, to some extent only we can reduce the focal length by compressing the lens. Okay, so this changing of the focal length, It is the ability of the eye lens to adjust its focal length so that the image is always formed. Whether it is far away from it means it will elongate, right? When the object is nearer to our eyes means it will compress. Okay, so, it will adjust the focal length so that always the image is always formed on the retina. The image is always formed on the retina. So these are all possible only the eye lens is made up of a flexible material. Okay, it is composed of fibrous and jelly like material so that it can be modified into some extent. Its curvature can be modified. Okay, next important point. Least we have said it to some extent only we can decrease the focal length, not fully. Okay, so the least distance of the distinction or near point of the eye. Near point of the eye. That means what? At what distance we can get a clear vision. Okay, minimum distance. It is a minimum distance at which the object can be seen most distinctly without strain. Without strain we can able to see the object. That distance is a near point of the eye or least distance, right? For the young adults, normal vision. For the normal vision, your near point will be 25 centimeter. If you keep the things in front of your eyes at a distance of 25 centimeter means you are able to see the object clearly without any strain. Okay, if you bring the objects closer to your eyes means you are not able to because after that it will not be compressed, right? See, if it is here means it is able to compress and you can get the focus here, but to some extent only it can be compressed, right? To this extent only it can be compressed means if the object is kept close, very closer to here means then you will get the focus point at this place, then you will not get the image, it will be blurred. Okay, so it has to be kept at a minimum distance of 25 centimeter from our eyes. Okay, so that your image will be formed clearly, right? Formed clearly. Likewise, you will have a far point of the eye also. Far point of the eye also. That means that is the farthest point up to which eye can see an object clearly is called far point of the eye. For normal person, the far point will be infinity. So we are able to see the objects clearly when the object is placed between 25 centimeter and infinity. If object is placed between 25 centimeter and the infinity, you are able to see the object clearly. The normal eye can see the object clearly that are between 25 centimeter and infinity. If you keep the objects near at 10 centimeter distance means you will not be able to get the clear image. You will get the blur image only. You will not be able to even read if you keep the book very close to your eyes. Okay. So you are supposed to keep the book at a distance of 25 centimeter. And one more thing is cataract. Cataract, it is a usual word, you would have heard this, right? It is a condition. Okay, if old people are there in your home means you would hear this word cataract. It is a condition in which crystalline lens of the people at old age becomes milky and cloudy. Okay, they said something is hiding my sight. They used to say like that, right? That is because of the milky and cloudy is called cataract. Okay, it causes partial or complete loss of vision itself. Okay, but it is curable. Okay, it is possible to restore vision through a cataract surgery. Clear? Okay, and that's all about the power of accommodation. What is meant by power of accommodation? Ability to change the focal length so that you can get the image at the retina always. Okay, whether the object is nearer to us or far away from us. Okay, then from the why do we know part, why do we have two eyes for vision and not just one? Okay, so the reason is we will get the we have some 4 points here. It gives us a wider field of view. Okay, if you have two eyes you will get a wider field of view. With one eye the horizontal field of view is only about 150 degree. Okay, if there is only one eye means it able to cover only 150 degree. This is fully means 180 degree. So 30 degree if you less this means only this much it can view. Okay, for one eye it can able to view only 150 degree, but if both the eyes are there, you are able to see 180 degree. Okay, you are able to cover 180 degree. But with two eyes, our field of view increases to 180 degree. Okay, next, the ability to detect faint object is enhanced with two detectors instead of one. Instead of say watching detecting an object with the one eye, if you detect with the two eyes, you can get the clear image, right? Next one, with one eye world looks like flat, that is you can get the only two dimensional view. Okay, with the two eyes the view becomes three dimensional. Okay, see in theaters also, the screen will be like this, two dimension only, two dimensional image will be giving. When you are wearing this 3D glasses, you are able to get the depth, right? You can get the three dimension view of the object, right? You can even find the depth of the object, right? So that is given here. Okay, with the one eye the world looks flat, that is two dimension only. With the two eyes the view is become three dimensional. Okay, as our two eyes are separated by few centimeters, each eye observes a slightly different image, right? When you are viewing the object from your two eyes, for example, here it will be like this, here it will be like this, right? Only a few centimeters different, so slightly the image formed by each eye will be different only, right? Our brain combines the two views into one, and we get to know how close or far away the things observed are. Okay, so you are getting two different images in the brain only. It will all the signals will be, light signals will be converted into electrical signals, and the brain interprets all this thing, and you will get a clear image, how far it is, how far the things are actually. Okay, we have taught about this three dimensional, right? That is called stereopsis. Okay, stereopsis is a simultaneous focusing of an object in both the eyes, enables us to perceive the depth of that object, that is from the two dimensional view to the three dimensional view. So before that your object can be seen like that, after that you will get a, after combining you will get a 3D view like this. Okay, because we are given some depth to that object, right? That is, overlapping of the image in the brain gives a three-dimensional effect of the images. Okay, that is called stereopsis. That is we are focused through the two eyes, right? So you will get two images. Okay, we can overlap the images, and you can get a three-dimensional view of that image. Okay, these are all coming under the do you know part. So you just know about all this thing. Okay, thank you.